Hello, hello, hello. Hello. Thank you. Okay, welcome everyone. Welcome to the PXC operator What to Know to Be Successful talk. Carlos Tutte. You probably already talked with me or saw me around on the expert booth. So, this talk will be specifically about the PXC operator. A few of you asked me some stuff. But if you want to ask me something else about the operator or, well, actually about whatever, you can join me on the expert booth later this evening. So, just some background about me. I'm a consultant on the professional services team. I've been working with MySQL and databases for long, and 5 years in Percona. And outside work, well, I do some stuff like everyone does. So let's get started because I have quite a lot of things to mention on this talk. By the way, are all of you familiar with the PXC operator? Or raise your hand, the one that isn't. Okay, I have good news for you. After this talk, you can tell your manager that you know all the features. And if you don't, you can still lie. So, okay, I will cover all of these one item at a time. So I won't, compared to the tutorial, I won't tell you how to deploy a cluster step by step, but actually I will tell you all the features and different possibilities for all that can be done on the PXC operator. For further examples and information, you can always check our official documentation and plenty of blog posts that we have. They are public and free. Okay, let's get started. First of all, the operator and PXC. Why? So first of all, what is an operator? In the context of Kubernetes, an operator is a client-side piece of software that will allow us to pack, manage, deploy other software or services in an easy way, in a robust way, automatically, in a reliable way, and easy to implement. So, again, for this talk, I will limit myself to the PXC operator, but some things I say do apply to other operators or to other MySQL products. Okay? So, why PXC? Because PXC combined with the operator has really nice features. For example, PXC has self-healing capabilities. If a node is down, crashes, or is just joining the cluster, it can self-heal, stream a backup of the other nodes, and join automatically. It does provide high availability. It's virtually synchronous replication. So you can potentially write to any node, although we strongly suggest writing to one node at a time, but makes failing over and load balancing quite easier. So, platforms supported by the operator. By the way, the latest version of the operator is 1.12.0. As always, we strongly suggest using the latest version. So for this version, these are the supported platforms and supported versions. You can see that we do support Google Kubernetes engine, Amazon, Azure, OpenShift, Minikube. So we cannot test every operator for all possible versions of all platforms. So the testing of the operator is done in some of the versions, which means that you can still use the operator on some different versions that are listed here at your own risk. Likely it will work, but depending how far are you from the supported versions, you might hit some issues. And we likely won't provide a fix for a non-supported version. So try to stick with the supported versions. Okay, operator and cluster deployment. Again, for those of you that arrived late. So this, compared to the tutorial, I'm not teaching you how to deploy a cluster. I'm showing you the features of what features are included on the operator and the different specs of it. So let me continue. When deploying a cluster, if you attended the tutorial, you know how to do it. You will see that you can deploy one operator per namespace or one operator for multiple namespaces. So on the left picture, you can see that on each box, there is one operator and a number of nodes, another operator and another number of nodes. So each operator or each box will be dependent from each other. So on the right box, you will see that there is only one operator and multiple namespaces that oversees all of the topologies. So each deploy will have its own pros and cons. So let me start with the right one operator to rule them all. So that can be done basically is having a huge file with a comma-separated list of all the namespaces that will be on the deploy. That will be a huge file, likely difficult to maintain, and mixing things, in my opinion, can be difficult. So maybe changing something for one namespace will end up breaking something else in an unintended way. So I would suggest using the left approach, which is one operator per namespace. That means you need to manage more files, but at least each file will be easier to maintain. Okay, about deployment. So in order to deploy a pod, you need to define the requirements, the hardware requirements for each pod. So for PXC, the minimum, so for a PXC cluster, the minimum amount of nodes should be 3. And the hardware requirements should be at least 2 gigabytes of RAM and 2 CPU threads, but likely, and depending on your workload, might be much more. So if you already have a PXC deployment, likely you will need to use around the same amount of hardware, hardware for your Kubernetes deploy as well. How do you request resources? So there is one file named cr.yaml in which you need to specify all the configuration for the Kubernetes deployment. On one part of the cr.yaml file, you need to specify the hardware resources. So the left box is, for example, for PXC. The right box is for HA proxy, load balancing. I will talk about that in a bit. So there is a resource section in which you can specify the requests and the limits. Again, the amount of resources, you need to tell yourself what you want, and you need to set up some values that match with the underlying hardware. Otherwise, if you request more hardware resources than available, the node will fail, won't deploy, or can even, according to priority, evict some other pods. So you need to watch out for the underlying hardware and utilization. Just a note, the default configuration, so we don't know what are your needs, so the default configuration will be just for a small environment meant for testing. So make sure that you set to edit the requirement, the hardware for your production deploy. Then, apart from specifying, for deciding if you want to use one operator per namespace or only one operator and selecting hardware resources, you also need to select which storage you will be using for saving the data. 3 choices: mtdir, hostpath, and OpenEBS. Each have their own pros and cons. So mtdir is like the local file system or a local directory of the pod, which will only live while the pod is alive. If it fails, breaks, or gets destroyed, so will the data. So for a persistent data store or for a database, likely that's not the choice you want, unless, of course, you are on testing or on an environment that you don't care about your data. Host path is manually creating a file system that you will then mount on the pod. And the last option is OpenEBS, or container attached storage. The suggestion is to use option number 3 because it allows for volume resizing without downtime. So as your dataset grows, likely you will need to, or you would like to enlarge the volume. So, well, it's OpenEBS, if possible, should be the option to go. How do you, so we saw that, yeah. So there are different options. Actually, I didn't dive too much. So I have like a lot of slides. So there are different options for deployment and different examples in our official documentation. So yeah, you need to configure something outside of the Kubernetes. Just filling something here on the CR YAML might not be enough to get it deployed. If you want, at the end of the meeting or later on the hallway, we can. Yeah, sure. So this is an example. So setting CPU and memory is quite easy, just a tag and a value, that's it. Setting the storage does involve a bit more metadata and tags and configuration and possibly setting up the storage somewhere else and targeting it from here. So this is just an example for AWS. So the default in this case, the default is GP2. If you want to aim for performance, maybe you will prefer to go with IO1, but that will be more expensive. So like many things, there is no best option, but usually it's a trade-off. Like I want a faster, reliable, bigger, depending on what you need, likely you will need to change the storage, okay? Yeah, was myself. So, and then something important I would like to mention that's also inside the CR YAML file is there is one section called finalizer that will have different values. So the finalizer section basically is a cleanup when the pod gets deleted or has some issue. So for a stateful or application or for a database, it's highly likely that you don't want to delete the underlying data. So by default, so depending on which operation version you're using, make sure that by default the delete PXC PVC is commented out so that when you lose the node or the pod, you don't lose the storage or what's on the disk volume as well. And well, the finalizer has some other stuff, and depending what you want by default, you should be careful if something is commented out. And about to finish up with the deployment section, something worth mentioning as well is affinity and anti-affinity. This is a concept for Kubernetes. So you can specify certain conditions or certain tags to define the behavior at pod creation and allocation time. So affinity is put this pod on somewhere that matches these conditions. So for example, maybe you want your pod to run on a certain server, on a certain disk, or in a place that will benefit the most. And there you also have anti-affinity, which is the opposite of affinity, like avoid this from happening. So, for example, one common case is for high-performance computing. Maybe you want all your nodes to be tightly coupled and all allocated in the same server, because if there is a high amount of data transfer between the servers, you want them to be close by, maybe to minimize some cost of data transfer, maybe to increase throughput and minimize latency. And you can also use anti-affinity to maybe do the opposite, spread out the servers so that if the hardware fails, not all the nodes will be down at the same time, but since they are located on different servers, any fault or whatever problem, the problem won't hit all of them at once. You can also say anti-affinity to avoid certain slow machines or certain slow disks, etc. Apart from affinity and anti-affinity, there is something called tolerance, which is not as strict as affinity. So let's say tolerance is, please try to do this. If you cannot match this criteria, then it's all good. Try do as best as you can. And last one, there is some concept called priority, which means basically that you set a priority for your different deployments. So if you need to allocate a high priority pod and there are not enough resources, Kubernetes might decide to evict some lower priority pod in order to be able to allocate the higher priority pod. So this section is quite large and complex. The examples are super large. So if you want to check this further, I invite you to check our online documentation. So I just wanted to mention this because it's an important concept. Okay, some other feature of the PXC Kubernetes operator is cross-site replication, which means that you have a PXC cluster on a primary data center, another PXC cluster somewhere else, and asynchronous replication in between the two. So the operator is smart enough to set up everything, but once replication is set up, it doesn't mean that all magic will happen and it will go flawlessly, but yourself need to monitor for replication error and for any other maintenance that you need to do on asynchronous replication. So this feature is available only starting from upstream 8.0.22 because in that version, asynchronous replication failover was implemented because in a PXC topology, only one node from each cluster are connected with the other cluster. And if one of the nodes connecting with the other is down, asynchronous replication failover will automatically try to resume replication, but from some other node. So that's the base of the requirement for this version. Again, you need to, like everything, you need to configure from the cr.yaml file. You need to set up certain flags and tags on the primary, certain others on the replica. There are a few more, but I wanted just to keep this simple. But on our online documentation, you have the full example to implement and test that. And in which cases would you like to set up cross-site replication? Usually, or what I use the most is for migrations. Usually, if you want to move, migrate versions or move your topology, you set up a replica somewhere else, set it up in advance, make sure that it works well, and when you have checked it in advance, you do the failover, which minimizes not only downtime, but chances of hitting issues that need to be resolved on the spot. Load balancing. The current version of the operator does support two different products for load balancing, which are HA Proxy and Proxy SQL. There is a huge difference between the two. Basically, HA Proxy is layer 4, network layer. It will reroute the TCP request and round robin between the nodes, or do the, well, depending how you configure it, but likely will be round robin. while ProxySQL is layer 7 or application layer, so ProxySQL will add extra overhead, but will have many features. So for those of you that doesn't know ProxySQL can do query mirroring, query caching, query rules. You can define weights and a lot more. So which one would you choose? It's up to you. If you don't need ProxySQL settings, ProxySQL features, maybe HAProxy will be good enough for you. But if you do need to set up ProxySQL, you have the option too, but maybe you need to add a bit more configuration on your end. So how do you set up configuration? You can guess again through the file cr.yaml, and you have two more options, config map and secret object. So let's quickly, okay. No, I will talk about these three options in a few. So for now, forget about what each of these is. So this is an example configuration for HAProxy. Depending on what version of the operator you are using, the defaults have been changing. Our tech lead, Marco Tusa, has done some benchmarking on these different values. Depending on the operator version, some defaults have been changed. And depending on your topology, workload, deployment, latency, you might need to adjust them a bit more. There are a couple parameters, readiness and liveness. These are super important because if you set them high enough, you might, the performance might be hit. But if you set them really low to aggressive values, maybe some pods will be taken out of the topology too quickly before they have a chance to recover or replay back. So the values for this is a trade-off. Again, our tech lead, Marco Tusa, did some benchmarking, and the newer versions of the operator have newer defaults that should be safer and better for performance. We have a blog post about this. And there is an operator calculator that will assist you in calculating ideal values based on the input. Currently, the operator calculator is on our tech lead, Marco Tusa, GitHub, but this calculator, he told me, will be merged into the main operator branch as well. Okay, user authentication and secrets. You can split users in two groups. One is application level users, the one that will be used by your application and for day-to-day operations. The other are system level users, which will be the ones needed for managing the different components and interactions. So for system level users, there is the list of users that are created by default. Administrator, monitoring, PMM, replication. Each will have a default password. They are known and public and unsafe. So it's strongly suggested to change the defaults, especially if you set up this on production. And if you need to create, so apart from these users, no other user is created by the operator. So if you want application users to connect from the application, you need to create them yourself. You need to log into MySQL and create them one by one. So you can either log into the container and then create the user, grant the privileges, or do all the user creation stuff. And one comment about users and authentication. So this is a change that happened on 8.0, both upstream Percona server and also on PXC. The default authentication plugin was changed. So you can still revert back the value from the new default to the previous value, and that will work. And that is needed if you have ProxySQL chosen as the load balancer. Otherwise, if you go with HA proxy, there shouldn't be any problem, as long as you also update the MySQL client. About users and passwords. So if you open the secrets.yaml file, you will see that there are all tags showing users and password for all the deployment, for all the deployed users. You can see on red and on green, there is a difference in the password. So both passwords, once deployed, will be the same. So for root, the root password will be root_password. But the difference is that on the right, the data is base 64 coded. So this doesn't mean that the data is encrypted. It will be just coded, so hidden at plain sight. With some effort, executing base 64, this command, you can decode these values. So string data is plain text. If possible, use data and the base 64 values. It's a bit more effort, but at least the password won't be on plain sight. Then environment variables, something else that you can configure when setting up the deployment are environmental variables that can be useful for example, for PMM, or to add some customization, maybe to HA proxy or to some other external software. So setting up an environmental variable is super easy. You just need to add these tags, and then on data, you just add the environmental variables, the name of the variable, and the value. Again, this should be base 64 encoded. Okay, changing MySQL options. Now I will talk a bit more about different ways of impacting changes or configuration. So if you already have a PXC deployment, likely the configuration that you will be using on the deployment will be exactly the same or mostly the same. There are certain variables that you cannot set when using the PXC operator. One example is this one, InnoDB dedicated server. So Nando Laudares, one consultant from my team, he filled a bug recently that this parameter in particular, if set on the operator, mismatched with the operator deployment and causes some issues. But other than this and maybe a few exceptions, you can use this very same configuration that you have on your current deployment, but for the operator. So let me tell you what are the three different options. So far, most of what I have said always relied on editing the YAML file that has the cluster configuration. So a YAML file is a big file with many tags, in which on one of them you can set the configuration and copy-paste your current configuration. Super simple. That's the easiest deploy. Then, of course, with kubectl, deploy the YAML, the deployment and the configuration will be applied. Another option is called config map. So you create or you have your original myCNF file, and you create a config map. So step 3, you create a mapping between that file and the cluster so that all the pods can accept, can check all the files within the same namespace. Likely, so you can maybe use one config file for all 3 nodes, unless you need to set up something differently, for example, auto increment offset or something different between the nodes. But otherwise, on a PXC topology, configuration and hardware should be the same for every node and every pod. And last, we have secret object. This involves creating, not editing CR YAML, but a new file called myPXC secret.yaml, in which you will, rather than copy-pasting the configuration in plain text, you will base64 code the content of the myCNF file. So this string here, all of this should be this. Okay. Okay, backup and restore. An important aspect of any database deployment is having the ability to take and restore backups. So the operator does support backups on the cloud, for example, AWS or Azure. Again, I try to keep this simple. So what you will see here is a really simplified version of how to deploy stuff. On the official documentation, you will have a much larger example because, for example, from here, I'm missing the keys for authenticating for the cloud environment. Also, you need to set up the storage in advance. So there are extra steps that need to set up apart from this. But at a high level, you can see that if you want to have backups on the cloud, you need to set up some configuration on the CR YAML. You need to target the cloud, set up some configuration, and once set up, should work flawlessly. If you want to have backups on the persistent volume, you also edit the YAML file, but the configuration will be slightly different. So there is a big difference between storing on the cloud and on a local file system. The problem with the local file system is that your disk might break, so you might lose the database plus the backup. And if you store the backups on the local disk, you cannot do point-in-time recovery. So point-in-time recovery, I will mention that in a bit. I won't get ahead of myself. A bit more about backups. So you can compress backups. The compress ratio is usually quite good by setting these green options on the configuration. And for taking backups, there are two different ways of taking them. One is on demand, whenever you feel like it. The other is on a scheduled basis, on a cron job-like way. So scheduled backups, yet again, you need to edit the YAML and put something similar to this, a tag with the backup, a schedule, and then in here you will mention like what's the policy for the backup scheduling. This is, in case you're not familiar with this is a cron job format. So minute, hour, day, month, and day of the week. So in this case, Saturdays at 0 minute, 0 hour, that's every Saturday, and keep 3 healthy backups. Then for taking on-demand backups, and this is, or at least this is what I find the most strange, because usually when I want to take a backup of a database, I type the command on the database and hit enter, but for PXC, or for the operator, you need to create a file named backup.yaml and create the configuration for the backup and then execute that YAML as many times as you like every time you want to do the backup. And something important to remember is the finalizer section. Again, remember to comment out the delete backup, because if at some point you delete on purpose or lose because of some issue the node, you might as well be losing the backups. So ideally you want the backups to persist the life of the node. And then finally we have the binary logs. So binary logs will keep track of all the changes that are all the write activity that is happening on the database. So if you intend to do point-in-time recovery, you should save the binary logs. Again, binary logs are only supported on the cloud. And you need to enable that with just some tags, as always. Okay, now we have backups. What do we do with the backups? Or if we have an issue and we need to restore a backup, how do we do that? This is important. Backups cannot be restored to empty dir or host path volumes. So you can make a backup from those volumes, but you can only restore to a persistent volume. So how do you restore? Again, it's not a command for restoring, but actually you need to create a YAML file with the configuration on how to restore that backup. So you need to specify the backup name, the storage in which the backup is located. If you want to do point-in-time recovery, up to which point in time you need to restore the backup. Same as with any database. If you want to do point-in-time recovery, you need all the binary logs since the last full backups. So if you push binary logs or if you push backups, you won't be able to get to the desired point in time. Okay, backup maintenance. Likely, and depending on your dataset size, you will only want to have a fixed amount of backups. Otherwise, it will be expensive to keep so many copies of the backup. So you can have a fixed amount of backups by setting backup.schedule.keep equal n, or the amount of backups you intend to have. So only successful backups will count toward that number. With 0, you disable that. And you can also manually delete a backup by using a delete, kubectl delete, and the name of the backup, which you can get with get rather than delete. So the API allows you to get and delete with that simple command. You can also make copies of the backup locally or somewhere else. So the backups, even though they are on the cloud, you can still access them, copy them, and do whatever you want with them. Encryption. So this is a feature, transport encryption, sorry. So that is SSL or traffic encryption between the nodes. For example, in between the PXC nodes or with a load balancer or some other tool or debugging tool or something else you might have. So you have the option of providing yourself the SSL certificates, or you can tell the cluster to generate himself. So I kept this super simple, but actually this is more complicated because if you generate the certificate yourself and need to renew them, there is some process which is described on the official documentation, but know that you have the possibility of either generating yourself or make the cluster generate himself, and then they can be rotated without any impact. And last, in red, it's strongly suggested to have SSL enabled. It does have some extra overhead for performance, but security first. Now, so the previous was transport encryption. Now that address encryption, so the data that's on the cluster can be encrypted as well. So encryption is actually a native MySQL and Percona server feature. What the operator does is setting up what's called the keyring vault plugin or HashiCorp vault storage, because when you enable encryption, you need the master key to be kept somewhere in a placed outside of the database that's safe for the database to retrieve the key if needed. So the operator will do that for you, will create the vault for you, and then once that is deployed, encryption will be or should be transparent to the end user. So you just need to create, set the encryption flag equal yes when you create the table, or you can do alter the table and encrypt the table if it wasn't created, encrypted by default. Monitoring. So the operator by default accepts and can be configured with PMM version 2. So you just need to, well, actually it's not that magical. You need to set up PMM yourself, and then on each deploy, you need to target the IP address of the current PMM server, and of course, enable equal true to set up PMM. Keep in mind that, so there is some configuration ongoing while the nodes do target and authenticate against the PMM server. So either go with the defaults or mind that if you change certain parameters, things might break or the nodes might not be correctly monitored. So remember that to keep that, to check that, and make sure that if you change some user that matches with some other user used for monitoring. So how to authenticate the clients? On the left, there is token-based authorization. On the right is password-based authorization. So starting from the previous version 1.11 for the operator, password-based is considered unsafe and is deprecated. So ideally, you should migrate to token-based authentication. So the steps are super easy. You need to go into PMM, settings and a couple menus, one button, generate the token, then copy-paste the token in here on the secret file, and it will work. Then monitoring is a huge topic, so I will keep it super simple. So PMM is for monitoring the database traffic and performance, but there are many other monitoring tools that can be used to monitor the same or some other stuff. Some of these are K9, Prometheus, Grafana, AFKey, and Loki. You can read more about this again on the official documentation, but let's keep it simple for now. Okay, maintenance upgrade. So on a deploy, you have the operator version and the PXC version. So that's two separate components that are tightly coupled. So when you upgrade the operator, you likely will be upgrading the operator version first. So in this case, is version 1.12. You can see here. So first, you should upgrade the operator with these simple steps. And the operator will do the deployment rollout. And once, I got ahead of myself, I will go back in a few. So then after upgrading the operator, only then you will have newer PXC versions available to then work on upgrading the PXC node version. So there are different types of updates. You can use smart update and a strategy. So for example, you can use recommended or stick with 8.0 or 5.7 or different options depending on your upgrade policy. So there are, yeah.
So recommended will also automatically do a major upgrade.
Will do?
If you use recommended, it will also automatically do a major upgrade.
Yeah.
Okay.
So whenever there is a new version, it will trigger an update. Actually, there are a few more flags that can be set, but I'm keeping this simple. Again, on the official documentation, it explains a bit better, more in depth, these options. But either recommended or never are the best choices, depending maybe for a dev environment, recommended and forget about it. For production, you might wish to disable the smart update and do it on demand or when you feel like it. For maintenance, something that eventually will happen is resizing of the volume without downtime. Remember, you need to use OpenEBS to have this possibility. And on the official documentation and on this blog post, you can also get the step-by-step for this. Should be easy, but the steps are long for me to cover at this time. And some other maintenance operation you eventually might need to do is gracefully stopping the entire cluster. You can do that easily with one flag called pause. So after you pause the cluster and you apply the configuration, all the nodes will be gracefully stopped until at some point only the operator pod will be running. If you enable or set pause equal false and apply the CR YAML once again, you will see that the deployment will be start all over, they will be resumed, and everything should go back to normal. So this is not an everyday thing, but keep in mind that if you need to stop everything for whatever reason, you can do it easily and in a safe way. Okay, I know we are close to the end, but let me finish a bit with this. Debug and troubleshooting. So a really important aspect of Kubernetes deployment is what to do when things go wrong. So on the newer versions, because this didn't happen on older versions, on newer versions now the logs do persist after one node gets killed. So if something happens, there is some error, a node never gets fully deployed or it randomly fails, you can still check what happened by checking the logs. You need to enable the log collection with log collector equal enabled, and then just kubectl logs and check the logs. If something fails, try to get the logs quite fast because eventually they will be rotated. And for monitoring, for troubleshooting, we have a blog post written by one Perconian, Sergey Bronin. He does, apart from log collector, he explains how to troubleshoot and get logs with troubleshoot. It's a shell script that will do some more magic that can be helpful when troubleshooting. Side containers. So sometimes you need to run some debug tools or have somewhere. So in the operator, you deploy the pod and you likely won't be installing stuff on the pod itself. So maybe if you need to have some data collection, some monitoring tool, some debugging tool, or something running along with the main PXC pod, you can create a side container, again, on the YAML file, specify the image, command, arguments, name, and whatever the sidecar will contain. And you can check them, access them, and log into them, same as with every other pod. Following the Kubernetes and container philosophy, you want one container per service or per product. So HA proxy will be in one container, the database in another, the monitoring tool in another, and so forth. That's why you might need to, if you need something else, use a side container rather than installing stuff on top of the other components. Side containers are a regular container, so you can do everything that you can do with any other container. You can attach volumes, attach files, mount file systems, same as with everything. Last, to finish, crash recovery. So this is an important aspect of PXC. It might happen that if the nodes were shut down in the wrong order, or if they crashed, or if something broke, the process for recovering a PXC cluster does require checking which node should be recovered first, than other. So PXC operator will do that work for you. He will be smart enough to know which node needs to be started first and which other after that. Otherwise, if you bootstrap with a node that is far behind the others, you might have data loss. So the automatic recovery is suggested. Else, if something fails or if you want, you can do the semi-automatic. And as a last resort, if something is plainly wrong, you can go with the manual recover. But this is the dangerous because it needs a lot of manual steps and you should know what you're doing. Otherwise, you risk breaking something or losing data. Okay, we're finishing. Conclusions. So the operator will make your life easier managing containers because it will have a lot of knowledge about PXC. He will know what to set up. You don't need, so deploying PXC can be complicated if you don't know how to do it. But with PXC operator can be a couple commands, really good. Problem is that adding Kubernetes can add a layer of complexity, but will add a layer of complexity to your topology. So it will make your life easier in an aspect, but will add a complexity and a cost at some other. So ideally, you want to be proficient with Kubernetes and have a good monitoring setup to know what happened and how to troubleshoot the stuff if some issues happen. Make sure to set up a correct configuration of the resources and limits, because if you don't do, you will end up with a much slower or worse performance than with your current PXC topology. And again, most of the things are automatically or have default values for when deployed, but you will need to also configure PXC, load balancer, etc., users, whatever, according to your configuration. So it's not that you press one button and all works flawlessly, but you also need to adjust things depending on your workload. And well, after this talk, I hope that you have taken a peek and learned the different features that the operator can handle for you to make your life easier. If you have any questions, let me know. I know we are short of time, but you can jump on me on the hallway. I will be this afternoon with our Kubernetes tech lead. So we will be able to answer any of your questions. And I will be around if you want to ask me anything. Or if you are hungry, you can run away as well. Thank you.